Picture an ocean on fire. Not metaphorically. Literally. Flames on water, smoke in the sky, oil spreading below the surface. In 2010, an offshore drilling rig exploded in the Gulf of Mexico. What followed wasn't just an accident. It was one of the largest environmental disasters in modern history. For 87 days, oil flowed unchecked into the sea. Not barrels. Millions of barrels. Oil didn't stay on the surface. It moved through water columns. It entered sediments. It coated coastlines. Marine ecosystems absorbed the shock. Now let's look at what actually collapsed. Plankton, the base of the marine food chain, was exposed. Fish larvae were poisoned before they could grow. Corals deep below the surface were damaged. Birds, turtles, and marine mammals were coated in oil. This wasn't visible all at once. Some damage took years to measure. That's the danger with marine pollution. The ocean hides evidence until systems fail. This long-term ecological impact was revealed through extensive scientific monitoring led by marine biologists and oceanographers studying ecosystem response to hydrocarbons. Their work showed that oil doesn't simply wash away. It persists in sediments, disrupts reproduction, and weakens food webs over time. Now zoom out. The Deepwater Horizon spill reshaped how the world views offshore energy risk. It raised critical questions. How safe is deep-sea drilling? Who pays when ecosystems are damaged? How do we value fisheries, coastlines, and livelihoods? The answers weren't theoretical. Fishing industries shut down, tourism collapsed, legal claims reached billions of dollars. Environmental damage translated directly into economic loss. This is why oil spills are treated as international concerns. Organizations like the United Nations, working through maritime and environmental frameworks and supported by scientific assessments from global marine programs, develop guidelines for spill response, liability, and long-term ecosystem monitoring. Their focus is not just cleanup, but prevention and accountability. Now here's the critical insight. Marine ecosystems can recover, but only partially and only slowly. Some species returned, others didn't. Recovery depends on depth, location, species sensitivity, and how quickly pressure is reduced. This means environmental damage has timescales longer than business cycles. Before we end, zoom out one last time. The Deepwater Horizon disaster teaches a hard lesson. Energy systems don't fail quietly. When they fail, nature absorbs the cost first, and society pays later. Environmental science exists to measure these hidden risks, guide regulation, and ensure that technological ambition doesn't outrun ecological reality. In the next episode, we'll shift from oceans to forests, examining deforestation in the Amazon, where land use decisions reshape climate, biodiversity, and global stability. This series is part of the Learning Studio, where real-world environmental failures are studied not for blame, but for understanding. This isn't about stopping progress. This is about understanding its consequences.